Hi viewers, welcome to my channel. I'm very happy to share another lecture on Compton Effect. In 1921, A.H. Compton discovered this effect. Named on that scientist, we call it as Compton Effects. So what is Compton Effect? When an X-ray beam is passing through a material like graphite, then two kinds of radiations will be observed. One is the radiation having with lower frequency or greater wavelength than that of the incident radiation. The another component is having the same frequency or wavelength to the incident radiation. So the radiation of unchanged frequency in the scattered beam is called unmodified radiation. The radiation of lower frequency or higher wavelength is called modified radiation. So that phenomena is called as Compton effect, right? The classical electromagnetic theory was failed to explain this Compton effect. A.H. Compton explained this effect successfully by using the Planck's quantum theory. Okay, so that is we will discuss in this topic, sir. So the phenomenon of scattering of X-ray photon while it is passing through the material like graphite, right? So the change of frequency, the decrease in frequency or increase in wavelength is called as Compton effect. The phenomenon of occurring the decrease in frequency or increase in wavelength of X-ray photon when it is passed through the material like graphite is called as Compton effect. Okay, so here what is happening? So in the Compton effect, we treat this as Compton scattering. Here, the elastic collision between two particles we consider. One is the photon of the incident radiation. The second one, electron of the scatterer. Okay, electron of the scatterer. So the free electrons existing in the graphite material. So one is the photon, another one is the free electron. So free electron is the scatterer, right, sir? Scattering material, graphite material. The free electron existing in the graphite material, the scatterer. So whenever the photon, X-ray photon is passing through that graphite material, that photon, here photon acts like a particle. That photon are subjected to the elastic collision with that free electron. So here we consider the elastic collision between the photon and the free electron in the scattering material, right, sir? So because of that, because of the elastic collision, all of you know that what is meant by elastic collision? The collision in which both linear momentum and kinetic energy are conserved is called as elastic collision. The collision in which only the linear momentum is conserved but kinetic energy is not conserved, that is called as inelastic collision, right, sir? So here the collision occurring between the photon and the free electron in the scattering material taken as the elastic collision. That's why kinetic energy is conserved and the total energy is conserved. And one more thing, linear momentum is also conserved. Using that concept, we derive the expression for how much a change in wavelength occurs. Okay, how much the wavelength changes for the incident photon and the scattered photon, that we calculated, that we derived the expression in this concept, right, sir? So let us consider a photon of frequency nu and wavelength lambda is passing through the graphite material. So after emitting from the graphite material, the scattered photon having the frequency nu dash, wavelength lambda dash. Okay. And the free electron that is scattering through the scattering angle, say theta, scattering angle. Okay. So that is, first you try to understand in the figure if you see this figure, it is very clear. Yeah. So this figure is very, very important. If you thorough about this figure, if you have the clear picture about this figure, you can explain the total concept, sir. Yes. So this is the incident photon. Observe very carefully. This is the incident photon of frequency nu, energy h nu, linear momentum h nu by c. So before that, I want to uh, recapitulate some points regarding the photon. What is the energy of the photon? According to the Planck's quantum theory, energy of the photon is equal to h nu, right? So that equals to h nu is equal to c by lambda. It is in terms of wavelength. What is the momentum of the photon? Momentum p is equal to mass into velocity of the photon, that is speed of light. That equals to, in another terms, we can write h nu by c. This is the linear momentum of the photon, right, sir? So keep these 2 points in your mind. Here, try to understand the figure. This is the incident photon of frequency nu and energy h nu, a linear momentum h nu by c, right? So that is colliding the free electron here. This is the free electron. Then some part of energy is transformed to this free electron. So that's why the electron will be scattered in this direction. Here electron is scattering in this direction. That electron is called recoil electron. Recoil electron. Here angle I have shown phi. This is a recoil angle. Angle of recoil or recoiling angle. Right. So now this photon, after transforming some energy, after importing some energy to the free electron, the photon will move with the rest of the energy. Therefore, this photon is called scattered photon. This photon is deviated from the initial direction. Initially, the incident photon is moving along the x-axis. So after the collision, the photon is moving at an angle theta with the x-axis. Here, the angle theta is called scattering angle. Theta is called as scattering angle. Phi is called as recoil angle. Right, sir? So this is, again, I'm showing, this is the direction of scattered photon. Right, sir? Now, the direction of a recoil electron. Recoil electron is moving along this red line direction at an angle phi with the x-axis. The X-ray photon, the scattered photon, is moving along the yellow line at an angle phi at theta with the x-axis. Since here angle is theta, here also this angle is equal to theta. So there also I have taken x-axis and y-axis. Just you have, this is x-axis and it is y-axis, right, sir? Okay. Wait. This is x-axis, right? Parallel to x-axis, it is parallel to y-axis. This angle equal to theta, right, sir? The scattered photon momentum h nu dash by c, energy h nu dash. Are you following? Incident photon frequency nu, scattered photon frequency nu dash, frequency changing from nu to nu dash. Incident photon energy h nu, the scattered photon energy h nu dash. So here also energy is changing, energy decreased, frequency decreased. Here the momentum h nu by c, incident photon, the scattered photon momentum h nu dash by c. Okay, here the momentum change, energy change, frequency change, obviously wavelength changes. But here, what happened in this elastic collision? Here, in the elastic collision, incident photon energy that is transformed to the free electron. Therefore, its energy decreases. That's why scattered photon energy somewhat decreases. Hence, h nu dash less than h nu. Momentum h nu dash by c less than h nu by c. And frequency nu dash less than incident photon frequency nu. Frequency is decreased. obviously wavelength increases because frequency and wavelength are inversely proportional. That's my point, sir. Since here angle is theta, angle of scattering theta, we are resolving this into two components. If it is a bar, ax equal a cos theta, and y component or vertical component, we write a sin theta. So what is the vector here? The vector is linear momentum vector. Linear momentum h nu dash by c. That is resolving into the two components. Then what would be the x component? X component h nu dash by c cos theta. H nu dash by c cos theta. And vertical component here h nu dash by c sin theta. Clear, sir? If it is momentum p dash along x-axis, x component p dash cos theta, y component p dash sin theta. But p dash is h nu dash by c. That's why we have written h nu dash by c cos theta. Here h nu dash by c sin theta. So that is one point to keep in your mind. Next. So this is the direction of recoil electron moving, right? Since here angle is phi, you can imagine this angle here also phi. It is the angle phi. It is also resolved into two components. The electron is moving with the speed v in this direction. Then momentum would be m into v, the momentum of the electron m into v, right? So resolving into the two components, x component, this is mv cos theta, and the y component or vertical component mv sin theta, mv sin theta. According to the relativistic concept, because of the electron mass is m, here electron mass, relativistic mass is considered, relative mass is considered. Then what is the equivalent energy? Mc square. Einstein mass energy relation principle, the equivalent energy to the mass m, mc square. Therefore, the relativistic energy of the electron is mc square. Right, sir? So this is the figure. Now, one more point. Initially, we are treating that here. Initially, free electron is at rest. The photon is moving with some momentum that is colliding with the free electron. Then some energy is imparted to the free electron. Electron is moving in this direction. So that is also called as a recoiling. Electron recoil through angle phi with the momentum m into v at an angle phi with the x-axis. The scattered photon is moving at an angle theta with the x-axis with the frequency nu dash, with the energy h nu dash, with the momentum h nu dash by c, with the wavelength lambda dash. Clear, sir? Got my point? Okay. Is it okay, sir? Yes. Now, so before going to the derivation, here you should consider some points that what is that? First, electron is free, which is at rest before the collision, which is colliding with the high energy photon. This is the point one. With the collision taking between incident photon and electron is elastic collision. The third point, after collision, the relativistic mass of electron is considered. Because electron is moving with very high speed, then relativistic mass or relative mass we are taking. Rest mass m naught c square. That is we know. If m naught is the rest mass, equivalent energy m naught c square. Right, sir? Before collision, let us write all the steps. Energy of the incident photon h nu, already explained in the figure. Momentum of the incident photon h nu by c. Rest mass of electron equal to m naught. Rest mass energy of the electron according to the Einstein mass energy relation m naught c square. Momentum of electron at rest or initially before the collision. Before the collision, electron are treated as at rest position because momentum of the electron at rest is equal to 0. Right, sir? Now, after the collision, now we are writing the steps. With that, energy of the scattered photon h nu dash, momentum of the scattered photon h nu dash by c. Here frequency nu dash, hence equal to h nu formula, Planck's quantum theory. According to that, we have written h nu dash. Momentum formula h nu by c. Since frequency changed from nu to nu dash, Here momentum h nu dash by c. Mass of electron moving with velocity v is equal to m. This is relative mass. Relativistic energy of electron mc square. According to Einstein mass energy relation, equivalent energy to the mass m mc square. Momentum of recoil electron, mass into its velocity, mass of the relative mass m, electron is moving with the speed v, hence momentum of the recoil electron coming to v. Right, sir? Very simple. Right, because the recoil electron moves at an angle phi after the collision. So we resolve into the two components. So that is I explained in the figure. A linear momentum component along x-axis mv cos phi. Linear momentum of electron along y-axis mv sin phi, that is shown in the figure, right? Similarly, the scattered photon momentum also resolved into the two components. X component h nu dash by c cos theta, and vertical component or along y-axis the component h nu dash by c sin theta. That is we see in the figures, right? Here the total energy is constant. Energy conservation is obeyed. The total energy before the collision must be equal to total energy after the collision. Right, sir? In any collision, whether it is elastic collision or inelastic collision, the total energy of the system must be constant. Here also we are taking energy of the system before collision equal to energy of the system after collision. So before the collision, photon energy h nu, since electron is at rest, rest mass energy m naught c square. Therefore, total energy of the system of two particles. So what are the two particles? One is the photon, the second one is free electron. Free electron is at rest. Since it is at rest, we are taking its rest mass m naught. What is the equivalent energy to the mass m naught? M naught c square. Therefore, the total energy of both photon and the free electron h nu plus m naught c square. Right, sir? Energy of the system after collision. Energy of the scattered photon h nu dash. Now the recoil electron is mass m, hence its relativistic mass energy mc square. Therefore, photon energy h nu dash and electron energy mc square. So sum of these two quantities gives the energy of the system after collision. This is the equation 1, sir. Okay. When you're writing the notes, you continue the running number, equations, running number. Applying law of conservation of momentum. First, let us apply the conservation of linear momentum along x-axis. Along x-axis, initially the photon is moving along x-axis with what momentum? H nu dash by c. Okay, so you consider this is x-axis and y-axis. Here the initially the photon is moving along the x-axis with the momentum h nu dash by c. Okay, here the free electron, it is colliding the free electron here, which is at rest. Okay, that's why initial momentum m1 u1 plus m2 u. Here the momentum of photon plus momentum of electron h nu by c plus 0 is equal to, after the collision scattered photon momentum along x-axis what? H nu dash by c cos theta plus recoil electron x component the momentum mv cos phi. Okay, now taking LCM, you will get h nu equal to h nu dash cos theta plus mvc cos phi. Okay, so from this mvc cos phi equal h nu minus h nu dash cos theta. This is the equation 2. Right, sir? Now let us apply the conservation of linear momentum along y-axis. Initially the photon is moving along x-axis. Right, sir? The photon is moving along the positive x-axis. So it has no velocity component along y-axis. Therefore, no momentum along y-axis. That's why 0. Because electron is at rest, its component also 0. Momentum component is equal to scattered photon y component momentum. The momentum component along y-axis of the scattered photon h nu dash by c sine theta. Next, minus mv sine phi. This is a recoil electron momentum because the electron is moving in the downward direction at angle theta. So here the y component or the y component of the momentum of electron along the negative x, the y axis. That's why we got minus sign here. So from this 0 equal h nu dash sine theta minus mvc sine phi. Okay. Therefore, MVC sine phi equal h nu dash sine theta. That is equation 3. Equation 3. Now, equation 2 and 3. This equation and this equation. Squaring and adding, sir. Squaring both sides and adding. So, what we get? M square, V square, C square, sine square phi. Plus, this is M square, V square, C square, cos square phi is equal to right side h nu minus h nu dash cos theta whole square plus h nu dash sine theta whole square. So that is written here. Okay. Now you observe very carefully only the simplification, but the observation is very important. M square, V square, C square common sine square phi plus cos square phi. Right side h nu dash sine square theta, h square nu dash square sine square theta plus it is in the form a minus b whole square. By expanding that, a square plus b square minus 2ab form, we are getting h square nu square plus not h cube. You correct this while you are writing the notes. H square nu dash square cos square theta, okay, minus 2h square nu dash cos theta, 2ab term. Left side sin square phi plus cos square phi equal to 1. Hence m square v square c square is equal right side h square nu dash square taking common sin square theta. Here it is also h square nu dash square cos square theta. So sin square theta plus cos square theta. Okay. Plus remaining h square nu square written here minus another term minus 2h square nu dash cos theta. Okay, sir. M square V square C square is equal to h square nu dash square, again sin square theta plus cos square theta 1 substituted, plus h square nu square minus 2h square nu dash cos theta. Right? Now, m square V square C square is equal to m square V square. Here also m type mistake. M square V square C square. M square V square C square equal to h square nu square plus h square nu dash square minus 2h square nu dash cos theta. Nu dash cos theta. Okay. Here also m square V square C square equal to in these two terms h square is taken. In these three terms h square is taken common. H square in bracket nu square plus nu dash square minus 2 nu dash cos theta. Right? From equation 1, we have h nu dash plus h nu dash h nu dash plus mc square equal to h nu plus m naught c square. How we got this expression? By applying the conservation of energy. Before the collision, total energy equal to the total energy after the collision. Using that concept, we have written this step. H nu dash plus mc square equal h nu plus m naught c square. This is the total energy after the collision. This right hand side term represents the total energy before the collision. From this mc square written as the subject, h nu plus m naught c square minus h nu dash. Mc square equal to h nu minus h nu dash, h taken common, nu minus nu dash plus m naught c square. Clear, sir? Again squaring both sides. Left side mc square whole square m square c power 4 equal to right side again a plus b whole square form. You will get h square nu minus nu dash whole square plus m naught the c square whole square, that is m naught square c power 4 plus 2ab term 2h into nu minus nu dash into m naught c square. Next m square c power 4 equal to h square. Again nu minus nu dash whole square expanded, nu square plus nu dash square minus 2 nu dash plus plus m naught square c power 4 written as it is plus 2h into nu minus nu dash into m naught c square. Okay. Now subtracting the equation 3 from equation 4, these two equations we are subtracting. Now m square c power 4, m square c power 4 and previous equation, not this one, m square c power 4 minus m square v square c square equal to, here the total term written h square into nu square plus nu dash square minus 2 nu dash plus m naught square c power 4 plus 2h nu minus nu dash m naught c square minus, there right hand side we have h square into nu square plus nu dash square minus 2 nu dash cos theta. Okay, sir. M square c square. In these two terms, m square c square is taken common. Then c square minus v square written back in bracket. Right hand side, here h square nu square minus h square nu square cancel. H square nu dash square, here minus h square nu dash square cancel. H square minus h square into minus 2 nu dash here. Here also minus into minus gets plus h square into 2 nu dash cos theta. So minus 2h square nu dash taken common. Then 1 here minus taken common. That's why again we are getting minus side here, 1 minus cos theta. Plus remaining term what? 2h into nu minus nu dash m naught c square plus this term m naught square c power 4. Okay. Left hand side, m square c square, again c square taken common. That's why m square c power 4 written here. Then bracket we get 1 minus v square by c square equal to RHS side minus 2h square nu dash into 1 minus cos theta plus 2h into nu minus nu dash into m naught c square plus m naught square c power 4. Okay, sir. Now that equal to m naught square, but m is equal to relative mass m naught by root of 1 minus v square by c square. Right, sir? Then m square equal to m naught square by 1 minus v square by c square. So there relative mass m is equal to, we are substituting this formula. Then m naught square by 1 minus v square by c square in bracket 1 minus v square by c square equal to RHS minus 2h square nu dash into 1 minus cos theta plus 2h nu minus nu dash m naught c square plus m naught square c power 4. Okay, m naught square c power 4. So here LHS 1 minus v square by c square, 1 minus v square by c square cancel. Then m naught square c power 4, sir. Here also c power 4 is missed. You have to correct this one. M naught square c power 4 here. M naught square c power 4 equal minus 2h square nu dash into 1 minus cos theta plus 2h into nu minus nu dash m naught c square plus m naught square c power 4. Okay. M naught square c power 4, m naught square c power 4 on LHS and RHS side cancel. Then this term brought left side, so minus changes into the plus 2h square nu dash 1 minus cos theta equal, on right hand side the term left 2h into nu minus nu dash m naught c square. Okay, both sides what cancel? 2h cancel, 2h is cancel. Then nu minus nu dash, this nu dash brought to the right side, nu minus nu dash by nu dash is equal 1h cancel, h by m naught c square into 1 minus cos theta. Okay, sir. Just simplification. Just we are rearranging the step. So again separating the terms, nu by nu dash minus nu dash by nu dash is equal h by m naught c square into 1 minus cos theta. Okay, 1 minus cos theta. So there nu by nu is cancelled, nu dash cancel, 1 by nu dash minus 1 by nu equal to right hand side h by m naught c square, h by m naught c square into 1 minus cos theta, 1 minus cos theta. Is it correct? M naught c square, it is m naught c square. Okay, yeah, m naught c square, yeah. So here we are multiplying with the C both sides. C by nu dash minus C by nu equal H by M, HC by M naught C square, one C cancel. Hence H by M naught C written into 1 minus cos theta. C by nu dash, that is the wavelength lambda dash, wavelength of scattered photon. C by nu, that is the wavelength of incident photon nu, lambda. Lambda equal to C by nu. C by nu dash represents what? Wavelength of the scattered photon. Hence, lambda dash minus lambda, that equal to right hand side. H by M naught C into 1 minus cos theta. So delta lambda, change in wavelength. Change in wavelength of the photon, delta lambda equal to the scattered photon wavelength minus incident photon wavelength, lambda dash minus lambda. So that we got H by M naught C into 1 minus cos theta. So this expression is known as Compton expression. So that wavelength, change in wavelength is called Compton shifts. Compton shift, Compton shift delta lambda. How much wavelength change? Okay, so between the incident photon and the scattered photon, how much wavelength increased? How much wavelength change? Here wavelength increased, frequency is decreasing. Okay, delta lambda equal to lambda dash minus lambda, that equal to H by M naught C into 1 minus cos theta. Here let us see some cases, sir. Here let us see some cases. In that formula, if theta equal to 0 substituted, cos 0 equal to 1, then lambda dash minus lambda equal to 0, lambda dash equal to lambda. Theta 0 means scattering angle 0. Scattering angle 0 means what? Incident photon is not deviated. Incident photon moving along the positive x-axis. So that is continuing along the same positive axis. There is no collision, no scattering, there is no change in wavelength. Right, sir? No change in wavelength because there is energy is not transferring from the photon to the free electron. In that case, we are getting the lambda dash equal to lambda. So that scattering is called unmodified scattering. Unmodified frequency, unmodified wavelength, unmodified scattering. Because there is no change in wavelength, there is no change in frequency, no change in energy, no change in momentum. Okay, when theta equal to 90 degrees, then delta lambda equal to H by M naught C into 1 minus cos 90, cos 90 0. So we will get H by M naught C. H Planck's constant value 6.62 in 10 power minus 34. M naught electron rest mass 9.1 in 10 power minus 31. C speed of light in vacuum 3 in 10 power 8. Substituting all these values in SI system, you will get meters and changing into the angstrom, that value 0.0242 angstrom. This is called Compton wavelength. So when the scattered photons scattered through angle 90 degree, so that means when the incident photons is colliding with the free electron, the scattered photon can move along the y-axis, then angle of scattering 90 degree. So then the change in wavelength would be 0.0242 angstrom. This value, that delta lambda value is called as Compton wavelength. Next, third case, when theta equal to 180 degree, cos 180 minus 1, then delta lambda, lambda dash minus lambda, lambda dash minus lambda equal H by M naught C into H by M naught C into 1 minus cos theta, 1 minus cos 180 minus of minus 1 plus 1. So that's why 2H by M naught C value will get. So that is 2 times to the Compton wavelength, 2 times to the Compton wavelength, right? When theta equal to 0, there is no change in wavelength. In that case, lambda dash equal to lambda. When theta equal to 180 degree, then delta lambda equal to 2H by M naught C. So that's why lambda dash equal to lambda plus 2H by M naught C. Okay, lambda plus 2H by M naught. Hence, the scattered photon wavelength changes from lambda to lambda plus 2H by M naught C. Okay, when there is no scattering, when theta equal to 0, lambda dash equal to lambda. When theta equal to 180 means what? Here initially the photon is moving along the positive x-axis. After the collision, it